Hey, look, it's you again. And here's your best friend. Now, let's say that your best friend's birthday is coming up in a week and you'd like to bake her favorite cake. So you've made this cake often and you know exactly what to do. So your process to solve this problem might look something like this. Go to the store, buy the ingredients, mix the right stuff in a bowl, put it in a tray in the oven, 350 degrees Fahrenheit for 30 minutes, and icing on the cake and present it on the day. So in this simple scenario, we are using what's called a predictive process. And it's sort of like a cannonball approach. You draw a target, which is your desired outcome. You then plan everything up front, factoring in any risks, and then you fire your cannon and execute your plan. Now let's take a look at the risk profile of this birthday cake project. If this were a project, we would examine risk in terms of demand and delivery. Demand asks the question, do they want it and can they afford it? And in this case, the answer is obviously yes. So the demand risk is low. Now let's also look at the delivery risk. Can we deliver the cake? We have a week, so we have time, and we've made this cake often before, so we know where to go for the ingredients and exactly what to do. So the delivery risk is also low, and the overall risk of the project failing is low. Now let's imagine that your friend loved the cake so much that you are inspired to create a business making and selling birthday cakes. And now what's changed is that you're essentially trying to satisfy someone you don't know personally. So you don't really know what he or she likes. And you want to make some money, so you need to sell to many people, and that means managing more variety of tastes and expectations. So let's now look at the risk profile of this project, starting with demand risk. Will they want it? We have to deal with a variety of tastes and competition. Can they afford it? Well, that depends on the cost of making the cake. So it's pretty obvious that the demand risk will be higher. What about delivery risk? Well, that would depend on what they want. Can we get their ingredients? Do we need specialized skills to make this cake? Do we need specialized equipment? So the delivery risk can also be described as higher, and the overall project is a higher risk of failing. With the cannonball approach, you'd plan up front, make the cakes, and try to sell them. But they may not sell, so how would you minimize this risk? You could make a few cakes and get feedback, and then go back and adjust your recipes based on the feedback till you get it right. Now this is called an adaptive process, and it's more like a homing missile. So you start once again by drawing your target, but the key difference here is that you acknowledge up front that this is a guess or a hypothesis, and you fully accept that the target may not be where you expect it to be, or that it may move after you're fired. So you're using a process that is flexible, and after firing, while you're in flight, you get a better look at where your target is, and you can take that feedback, adjust mid-flight as needed, and if the target has moved, you can still hit it. So why are we talking about this stuff? Because 15 years ago, almost all software development followed a cannonball approach, and that approach was called waterfall development or stage gate development. It began with a target being drawn with the assumption that you can figure everything out up front, and the target here of course is what the customer wants, that is product requirements, and you do all your analysis up front, and then you try to figure out your requirements and design based on those findings. And the analysis and requirements definition could take months, and once that's completed, you'd pass that on to your development team, who would then build based on those requirements, and then the development team would then pass that on to testing, and once it passes testing, it would then go into release. And that is when the cannonball would be fired, at which point you would then do a lot of analysis to see whether you hit your target. Now, the major flaw with this approach was that it always assumed that you can figure out what your customer wants up front, and that your development team can deliver what you've designed. And it also assumed that things won't change during the build process. And with waterfall, teams often felt that going back up to a previous stage or going up the waterfall was a sign of project failure and not really a sign of learning. And the net result of this approach was that a lot of software projects failed to deliver. And what was delivered was often late, with costs exceeding what was originally budgeted, and what was built and released was often not used. In fact, research in 2002 showed that half of what was being built was not being used. And over the years, faced with this history of failure, the industry started to recognize that software development has a lot of inherent uncertainty. In fact, if you were to plot your demand and delivery uncertainty on a graph, you might get something like this. So projects like our birthday cake for a friend would fall into the simple category, and our birthday cake business might fall into the complicated category. But the reality is that most software projects would sit in this third category reserved for the truly complex projects. But why is that? Well, technology is evolving so rapidly that companies are always trying to hit a moving target. And customer demands are also constantly evolving as they get exposed to new and better products. So by early 2000, most companies were deeply entrenched in their waterfall way of building software, but faced with these failures, thought leaders began to recognize that something was wrong and that new approaches were needed. And in the next tutorial, we will look at how on Feb 2001, a group of pioneers met and over the course of 2 days laid the seeds that started a software revolution. Okay, we're done for now, and I will see you soon.